Hi, chemistry students. This is your first lecture on Unit 4, which is on the atom. It's PowerPoint number 1, Notes on Atomic Anatomy. And I've given you the unit workbook, and actually the notes for this unit are in the unit workbook. You should turn to page 7 of your unit workbook, and you'll see a set of notes like this, just one page that you should fill in as we work through the lecture. So let's get started. So, notes on atomic anatomy. So what do you remember from 8th grade about what an atom looked like? Well, this is the basic view of atom that you probably learned in the 8th grade and the 6th grade and in elementary school. So we have a dense center part of the atom that's called the nucleus. It consists of protons and neutrons. And then outside, we have these electrons that kind of zip around and fill up most of the space of the atom, but are also very, very small and outside the nucleus. So if you look at your notes, you'll see number 1 is a table that talks about the particle name, the mass, the charge, and location of each of these subatomic particles, smaller than the atom particles. Along the first column here under particle, you should write the names, proton, neutron, and electron, and we're going to then fill in the mass, the charge, and the location of each of those particles. So starting with the proton, a single proton has a mass of 1 what's called atomic mass units. It's a special unit that is used just for measuring subatomic particles and atoms. It's proportional to grams, so if I had a mole of protons, they would weigh 1 gram. But if I have just a single proton, it weighs 1 atomic mass unit. The proton has a positive charge. If you have 1 proton, you have 1 positive charge. If you have 2 protons, you have 2 positive charges. And the proton is located in the center of the atom in the nucleus. Next comes the neutron. The neutron is also located in the nucleus. It is about the same size as a proton, has a value of 1 atomic mass unit. However, it is electrically neutral, so its charge is a 0, and it is also found in the nucleus. Finally, there's an electron. Now, we consider the electron to have a mass of 0. It actually isn't 0, of course, because it is a particle. It's actually 1 over 1837, that fraction of an AMU unit. However, it is so small that when we're calculating the mass of a single atom, we don't add it to the mass. It just doesn't make that big of a difference. So we consider the mass to be 0. It has an electrically negative charge, kind of balances off the protons, and it's found in what we call the electron cloud, which is outside of the nucleus. Okay, now moving on to number 2. You'll see in bold it says, all atoms of the same element are identified by their atomic number or their number of protons. You might want to underline atomic number and number of protons. That's a definition you need to know. So underneath, we've got to define a couple of things. First of all, the term atomic number is the number of protons. It's the ID number of that particular atom. So for example, if you look on your periodic table and you see that carbon has an atomic number of 6, that means that all carbon atoms will have 6 protons. If you have an atom that has 6 protons, it's carbon. On the other hand, if I have an atom and it has 16 protons, it's going to be a sulfur atom. It's never going to be carbon. If it has 16, then it's going to be a sulfur atom. It's sort of like your ID number. If somebody puts in your ID number, your picture will come up. Same thing with an atom. If you put in their number of protons, that identifies what the element is. We also have something called a mass number. And again, how heavy is that particular atom? Well, if you go back and you realize that protons and neutrons are the only particles that have mass and electrons don't, the mass of any given atom is just going to be the sum of the protons and neutrons, because 1 proton is 1 and 1 neutron is 1. So however many you have, you'll add them. Now, if you look at these two things here, if mass number is protons plus neutrons, and atomic number is number of protons, in order to calculate how many neutrons you have, you just have to take the mass number and subtract the atomic number from it. So the protons plus the neutrons minus the protons will give you the mass number. Okay, so that's number 2. Let's look at number 3, which is a little bit longer. It says atomic number is not always equal to the number of electrons. Now, you've heard the term atoms, and atoms are electrically neutral. That means there's no net charge. There's no net positive or negative. So in the case of an uncharged atom, protons, which are positive, will equal electrons. So however many protons you have, you'll have that number of electrons. So you want to fill that in. However, there are these things called ions, and ions are charged atoms. We have two kinds of ions. They're cations that are positively charged. You might remember that there's a T in the middle of this word cation, and it's not cation, it's cation. And so that plus sign looks a little bit like the T. That is a charged atom that is positively charged, which means since protons are positively charged, you have more protons than electrons, greater than protons than electrons. An anion is a negatively charged atom. Okay, so that means that you have more electrons and fewer protons. Now, to determine the charge on any given atom or ion, you simply have to take the protons, which are positive, and subtract the electrons, which are negative. And we'll see some examples of those. So that's how you calculate the charge. Now, a couple of other terms. Atoms of the same element can be different. Okay, not all carbon atoms are exactly alike. Now, they are alike in one way. All atoms of the same element have the same number of protons. So you're filling in that blank with the word same. However, there are these things called isotopes. Isotopes are atoms of the same element that have different number of neutrons and different masses. So they're the same element. They have the same number of protons, but they have a different number of neutrons, and that makes their mass different. Now we can write isotopes in two different ways. So you see ways of writing isotopes, and you see in bold symbol dash mass number example. So there are two different isotopes of carbon. They're carbon 12 and carbon 14. This is one way of writing that, C-12 and C-14. There's another way. This is the mass number as a superscript and then the symbol, and you can write it carbon 12 like this, or carbon 14 like this, with the mass number being up here right before you see the symbol. Okay, let me give you an example though so you can kind of see what this means. So for example, what's the difference between carbon 12 and carbon 14? Well, you can see here's a model of carbon 12. It has 6 protons, 6 neutrons, and 6 electrons. It's electrically neutral, but you can see that in its nucleus, it has 6 protons and 6 neutrons, and that adds together to be 12, the mass number. Okay? It's carbon, though, because it has 6 protons. On the other hand, here's another isotope of carbon, another form, sort of like triplets, but one of them is a little heavier, or two of them are a little bit heavier. So you have carbon 13, and the only difference between carbon 12 and carbon 13 is that carbon 13's had an extra donut. It's gotten a little bit heavier. It has an extra neutron in its nucleus, so it has a mass number of 13. Carbon 14, a very important isotope if you're radioactively dating things, has actually 8 neutrons in its nucleus. Okay, let me give you another example. Here are two very important isotopes. This is an isotope of uranium-238 and an isotope of uranium-235. You can see they both have 92 protons, okay? But uranium-238 has more neutrons, as you can see. So these two numbers here, 92 and 143, add up to uranium-235. Now, what's the difference? Well, there's a huge difference in uranium isotopes. You may know that uranium is radioactive, and it is. You also might know that uranium is sometimes used as bomb-making, nuclear bomb-making material. But what's key about this is that uranium-238 is the most common isotope, and it's radioactive. It'll kill you if you sit next to it long enough, but it won't explode, okay? Most uranium is uranium-238. You don't want to be near it because it'll make you sick with radiation sickness, but it doesn't explode. On the other hand, uranium-235, which makes up less than 1% of all the uranium atoms that exist on the Earth, if you get enough of it together in one place, will explode. It's fissionable. It's radioactive as well, but if you get enough uranium-235 in one place, it will explode. Fortunately, most of the uranium is uranium-238, and so when you mine uranium, it's going to be a mixture of these two, and the uranium-235 won't be concentrated enough to explode. However, one of the things that these nations that want nuclear bombs want is fuel that will explode. And so they have to go through a lot of different ways of trying to what they call enrich uranium, which is to increase the amount of U-235 that is in one place so it will explode. But as you can see, these are two different isotopes of uranium. They still have 92 protons each, just different numbers of neutrons. Okay, moving along. So let's think about this. How are isotopes the same and how are isotopes different? See if you can think of some ways, and then we'll review them here in just a minute. So how are they the same? Well, if you're an isotope, you're the same element. So you have the same symbol, you're the same element, you have the same number of protons, and basically you have the same chemical properties. Not identical, but very similar. How are isotopes different? Well, you have a different mass number, you have a different number of neutrons, and you may have some differences in your properties. Okay, so let's review the notation one more time. So when you look at notation here, on an atom, this would just be a single atom, you can see the mass number is here. That's the number of protons and neutrons. So the mass number is protons and neutrons. You have the atomic number, which is 2, which is just the number of protons. You can find that on the periodic table. Now, if I wanted to know the number of neutrons, I would just subtract 4 minus 2, and I get 2 neutrons. The charge is just protons minus electrons. And so if the charge in this case is neutral, is 0, and we have 2 protons, we would also have 2 electrons. Now, what if you have an ion, though? How does this notation change? Well, here's a notation for a sodium ion. You can see that its atomic number is 11. It has 11 protons. Its mass number up here, protons and neutrons, is 23. Okay. Now, how do you figure out the number of neutrons? You just have to subtract these two numbers. 23 minus 11 gives you 12. The charge is a positive 1. So if we have 11 protons and we want a positive 1 charge, we must have 10 electrons. So that would be 10 electrons. Okay. So you have this example table that you're going to fill in. And I'm going to go through the first one with you in detail, and then I'll put up the answer, and then I want you to try the others, and then pause the tape, and then see if you're right. I'll put up the key. So here's the first one. This is lithium 7, okay? So where am I going to find its atomic number? Well, I'm going to have to go to the periodic table and find its atomic number. If I do that, I look on the periodic table, I'll find that its atomic number is 3. The mass number is going to be right here. We don't even have to look. It's 7, okay? So the atomic number is 3, number of protons is 3. Here, I'm going to show this to you. So number of protons is 3, so the atomic number is 3. You can see those two numbers match. The charge, though, is 0. So 3 minus 3, because here are the electrons, should equal 0. So we have 3 electrons. Now, how many neutrons? Well, we have a mass number of 7 and an atomic number of 3. You could even write a little teeny 3 down here, and that would give you the atomic number, and then you could do the subtraction, and that would be 4. And again, the charge here is just 0. Now, see if you can do the other ones. Pause the video. See if you can do the other ones. Remember, the charge on these is not equal to 0. So you're going to have an unequal number of protons and electrons in these. And you'll want to write whether it's a cation or anion. So take a minute. Here are the answers. And just to go over this quickly, you can see that this is a positive charge. So that means that the protons minus the electrons should equal positive 1. So 11 minus 10 would give you positive 1. And it's a cation. That's a positive ion. On the other hand, you've got 16 is the atomic number, so 16 protons, but we've got a negative 2. We've got to have protons minus electrons equaling negative 2. So 16 minus 18 gives you negative 2. Okay? So we will be going over these in more detail, but I'm going to ask you to do some homework tonight to see if you can figure this out, and you have now completed your lecture.